In this video, we're going to have a look at sketching an Argand diagram and sketching loci in specific. So just in general, I'm going to put an equation here that's going to help us in this question. But yeah, just before we do that, I'm just going to increase the thickness of the pen. So when an expression is written in this format here, is equal to r, we say the center of the locus or the circle is given by AB, where A is the real part of this component and B is the imaginary part, and the radius is just, well, the right hand side. Talking about this specifically then, what we have to do is factor out -1 from the real and imaginary part. So when we do that, well, to go from if we think about this, it's like a -1 to -1 here. It's just a positive 1 that we put in, but you have to be careful with the imaginary part because it's actually a -i that we put inside the bracket, because minus of -i gets you to that positive i that we're looking for. Close brackets is equal to √2. That tells us that the center of the circle is given by, well, the real part here is just 1 and the imaginary part is -1. And then the radius is equal to √2. When we sketch an Argand diagram, we say the x-axis is the real axis and the y-axis represents the imaginary axis. If our center is 1 -1, that's 1 along the x and the -1 across here. So let's write that out very briefly. And you have to be very careful here because there's a specific radius of √2. That tells you that it's going to cross through the center. How we know that is if we form our own right angle triangle. Let's do it like so. If I form this right angle triangle, we know the difference in y-axis is 1. We know the difference in the x-axis is 1. And if you use Pythagoras' theorem, the square root of 1 squared plus 1 squared is equal to √2, which is why the length from the center to the origin is actually the radius of the circle. So when you sketch this circle, so it's a horrible diagram, but it'll look something like that. Well, it'll look a lot better than that, but hopefully you guys get the expression, get the idea. All right, let's now move on to part 2, and let's do it in a different color. Once again, I'm going to increase the thickness of the pen. I don't know why it's so thin today. So in the next part of the question, it tells you to sketch the region represented by this here. So we've already drawn on the modulus of all of this expression is equal to √2. So where it's greater than or equal to 1, well, that means that's where the radius is equal to 1. Now, if you put this in your calculator, it's 1.4 something, I believe. But the idea is that the radius of this other circle is going to be smaller. Not only that, but the center is going to stay the same. So it looks something roughly like, and actually it's going to touch the axis, isn't it? If the radius is 1. Because if this is 1 -1, you have to go 1 up in order to have a radius of 1 for a circle. So it looks like an enclosed circle within this region, but it would cross the x and y axes at 1 and -1. And then the region that we're interested in is where the circle is in between these two. So that's this shaded part here, the part in between these two circles. Hopefully this made sense, but I know my diagram's horrible. I was thinking about whether to make a video on this topic. But yeah, regardless, I have a lot of videos and a lot of different topics in A-level further maths, so be sure to check out my channel. Be sure to like and subscribe if it did help, though. I'd appreciate it a lot. Thanks for watching your video. I hope it helped. If you have any tutoring inquiries for A-level further maths, be sure to hit my website up at www.excelineducation.co.uk.